Section 3.5, Arithmetic Sequences as Linear Functions. Our essential question today is how do you make a table and a graph for an arithmetic sequence? Okay, our first problem says make a table, graph, and equation to represent this situation. Jim is saving box tops for his school. He already had 2 box tops before he started his collection. The total number of box tops he had collected each week for 5 weeks is given by the sequence 5, 8, 11, 14, 17. Okay, so we're going to make a table, a graph, and an equation. So first of all, we have our sequence 5, 8, 11, 14, and 17. So in my table, I need weeks and box tops. Now, reading this situation very carefully, I happened to notice that it said he had 2 box tops before he started his collection. So those two box tops that he already had, I'm going to put at the beginning, and that's after 0 weeks, because he had them before he started his collection. So he's collecting each week for 5 weeks. After 1 week, he had 5 box tops. After 2 weeks, he had 8, 3 weeks, 11, 4 weeks, 14, and 5 weeks, 17 box tops. So the tricky part about taking the sequence and making a table for it is that the sequence was starting with week one. And in reading the problem, we did know the value for week 0, which would be before he started his collection. So be careful and make sure that you understand that this sequence, when it's written up above, because we learned how to write our equations, f of x equals mx plus b. And when we write our equations, we have our common difference. And we have the first term in the sequence. And our first term, very specifically, was when x equals 0. X equals 0. So our first term up here, this is when x equals 1 for 1 week. So I technically need the 0 value, which is like going backwards. My common difference on the sequence, these are going up 3 every time. And then my first term, when x equals 0, if I go back 3, that gives me the 2. F of x equals 3x plus 2. So again, making sure you understand this, the sequence as it was given did not start at x equals 0. It started with week 1. So it was week 1, 2, 3, 4, and 5. So we need to figure out the value for our sequence when x equals 0. So we've got to take the common difference, go back to find the value at x equals 0. And it's also given over here in the word problem. He already had 2 box tops. So there's 2 different places that you can find this value for your table and this value for your equation. Okay, so we've got our table, we've got our equation. Now I just need a graph. The graph can be one quadrant for this situation. I'm going to put weeks on the bottom and number of box tops on the side. And I could go by 2's. So 0, 2, 1, 5, 2, 8, 3, 11, 4, 5, 8. Here's my graph. Remember that arithmetic sequences are linear. Arithmetic sequences are linear, so you should expect your graph to be a line. So we've got our table, we've got our equation, we've got our graph. Example number 2, make a sequence, graph, and equation for this situation. Emma opened an account with an initial deposit of $50 to save money for a new phone. The account balance each month for 4 months is shown by the table below. So the month, January, February, March, and April, and the amount she has saved. $85, $120, $155, and $190. So we need a sequence, a graph, and an equation. So I'm going to start with my sequence. In my sequence, I could take the values from the table. It looks like this. Okay? Now, I'm going to go back to my word problem, and I'm going to think about this $50. In my sequence, if she had an initial deposit of $50, and then this is the account balance each month for the next 4 months, $50 needs to be the first term in my sequence. Because she started with $50, so that would be the value for x equals 0. Then after 1 month, she had $85. After 2 months, $120. After 3, $155. And after 4, $190. So remember, when you're writing your sequence, to get to your equation, you really want to have the value where x equals 0. Because now my equation is going to be easier to write. F of x equals mx plus b. M is the common difference. Common difference. How much is going into the account every month? Remember, you can find that by subtracting 2 of the values. So if I subtract 85 and 50, I see that the common difference is 35. So she is putting $35 in each month. I could check that. And make sure that each time it's $35 being added, and I would see that it's correct. Then the first term in the sequence when x equals 0 is $50. So that's why I went backwards on my sequence to add in that value for x equals 0, because I knew I needed it for my equation. So I've got a sequence, I've got an equation, now I need a graph. One quadrant again for my graph. And on the bottom I can put the months. And then the amount of money, I'm going to go by 25. So I've got the month, and I've got her account balance. Okay. So when she opened her account, she had $50, and then 85 in January, 120 in February, 155, and 190. There's my graph. Now there are two questions at the bottom on this one. How much money is Emma adding each month? She's adding $35 a month. We found that out. So Emma is adding $35 each month. And then when will she have enough money for the phone if it costs $550? So I can take my equation, f of x equals 35x plus 50. And I can use my equation to figure this out. If the phone is $550, I can solve this equation to figure out when I will get to $550. I could also graph it or extend my table. So you can use any of those methods. I think that the equation is the easiest, so I'm going to solve the equation. So I'm subtracting the 50 that she started with. So basically she needed $500. So if I divide 500 by 35, I get 14.28, and then it keeps on going. So after 14 months, she wouldn't quite have enough. She needs that 15th month. So she will have enough money after 15 months. So 1 year and 3 months. Okay. Example number 3, make a sequence graph and equation for this situation. So we have a table again. Jill has $400. Her balance after paying her health club membership each month is shown below. So we have our table with January, February, March, and April again. The amounts of money this time are going down each time. And then we have two questions. How much does Jill's health club charge each month? And how many months can she afford to be a member? So I'm going to make a sequence again to start us out. So our sequence has 372 from the table, 344, 316, and 288. And again, I get one number, $400, from reading the problem. The amount of money that she started with was 400. Then I'm going to write my equation. F of x equals the common difference. How much is it going down each time? If I subtract 400 and 372, how much is it going down? So 400 went down to 372. It went down 28. Down $28. So that means negative 28x plus 400, because that was the value at x equals 0. All right. So I've got a sequence, I've got an equation. Now I need a graph. January, February, March, April again. That would be the month. And we can go with account balance, because we're talking about how much money she has after making her health club payments. And we are going to start at, we had 400, so I am going to go by 50s. Okay, so she started at $400. Then after January, she had $372. February, she had $344. March, $316. April, $288. So our graph looks like that. It's going downhill. And then we've got 2 questions to answer. How much do they charge each month? So they charge, we found this value already because this was our common difference. So $28 is how much her account was going down. So they charge $28 a month. Then we need to know how many months she can afford to be a member. So I'm going to use my equation. F of x equals negative 28x. F of x equals negative 28x plus 400. And I want you to think about the account balance. What would her account balance be? What are we looking for to figure out how many months she can afford to be a member? It's going down 28 each month. To use the equation, we're looking for when her money is gone. So that means 0. 0. So we're trying to figure out how many months it's going to take for her to have no money left. So this f of x is the account balance. And this x in the equation is the number of months. So that's what these variables represent. So if I subtract 400, I'm going to get negative 400. So basically, I'm dividing 400 by 28. A negative divided by a negative is a positive. So 400, that's how much money she had, divided by $28 per month, 14.28 ... So just like the last one, only in this case, it's not going to round up. She can't afford 15 months for her membership. She can only afford 14 months. Or he, I better reread my problem. She, it was Jill. So she can afford to be a member for 14 months. So a little bit over a year. Okay, so hopefully you have a good understanding of how to take a table, a graph, an equation, or sequence, and write all of those other forms. Please write a summary answering your essential question and check with your teacher for your homework.